Here we've got two particles, one of 5 kilograms and one of 4 kilograms, and they're connected by a light inextensible string that runs over a smooth pulley. For this question there's no friction anywhere. What are the forces acting? Well, here we've got the weight, so that's 4g. Here we've got a weight which is 5g. There's a normal reaction, which we can call R, and there's obviously a tension in the strings which is acting on the particles. So the string tension is acting in that direction as far as the 5 kilogram weight is concerned, and it's tending to pull this one up, so that's in that direction. Because the pulley has no friction, these two tensions are equal. What we can do is we can consider F equals ma on each of the particles. So for the 5 kilogram weight, what force is acting on it? Well, there's a tension acting that way, there's no friction, and because the particle is accelerating in this direction here, let's call that A, we can say T equals 5A. Where did that come from? That's force is mass times acceleration. As far as the 4 kilogram weight is concerned, there's a 4g acting downwards, but there's a t opposing that. So that 4g is pulling it this way, but the tension is pulling upwards. So the resultant force is 4g minus t. So force is mass times acceleration. Clearly both particles must be accelerating with the same value. So we've got two equations. Let's label those 1 and 2. If we add 1 and 2, that will get rid of the tension. So t minus t is nothing, so 4g equals 9a. So a is 4/9 of g. I can substitute that into equation 1, and the tension is 5 times 4/9 g, which is 20/9 g. Here we've got two particles, 6 kilograms and 3 kilograms, attached by a light inextensible string, both hanging from a pulley. What forces are operating on these particles? Well, clearly we've got the weight, which is 3g here and 6g here. There's a tension in the string. Because it is a frictionless pulley, those two tensions are equal. There's obviously the particles are accelerating, and obviously it's in this direction because 6 is bigger than 3, so the whole thing is moving like this. Let's consider F equals ma for each particle. You can write using Newton's second law. And if you really want a shorthand, you can write n and then an old-fashioned 2. So on the 6 kilogram particle, the force acting downwards is 6g, but that's being opposed by the tension acting upwards. So that's the force. The mass is 6, the acceleration is a. For the 3 kilogram particle, it works in the other direction because the tension is pulling it up and the 3g is opposing that. So t minus 3g equals 3a. Let's call that equation 2. Now let's add those equations. That's 1 plus 2. 6g minus t plus t minus 3g, that's 3g. That's because minus t and plus t is nothing. 6 minus 3 is 3. 6a plus 3a is 9a, so therefore a is 3g over 9, which is g over 3. Substitute that into 1 or 2. Let's use 1. 6g minus t equals 6a. 6a is 6 times a third g, so that's 2g, so therefore t equals 4g.